but one of my designs that I have a patent on from that job won an award in the US and it won an award in Canada. So I used to have a sticker on my door that I'm an international award-winning inventor of illegal garbage.
Hello and welcome to Beyond Me, the show where mechanical engineering students go beyond ME, and where the things we talk about are beyond us. We like thinking broader, we like thinking deeper. I'm Ben.
I'm Liam.
And I'm Finian.
Today we talked with Professor Leipold from our university, and we stayed pretty far within engineering. So we did a deep dive on computer-aided design. We talked about teaching with technology and the future of engineering.
And we're on video now, so go head over to YouTube or Spotify, leave us a like, comment, or review. It really helps us out. Let's get into it.
Professor Leipold, thanks for being here today.
Yeah, no problem. I'm excited.
Want to give us a quick background? What do you do here at RIT?
Great. I teach the CAD classes in mechanical engineering, which is such a gift. So I teach freshman CAD, which is a part of a really big course with a lot of moving components. And then I also teach a advanced CAD class. Mm-hmm. And on top of those, I also teach statics, which is a freshman core CAD or engineering course. I'm a lecturer, which I like to say when we're hiring new lecturers, I get to do engineering with the summers off. I get to teach without having to deal with parents. Mm-hmm. And I get to do academia without having to do research and grants. So I really feel like this job is just the sweet spot of a lot of intersections.
And do you have a favorite of the three classes to teach?
I like them all. And I know a lot of faculty like to teach different courses to change things up. I feel like CAD is one of those classes that's always changing, and I always get to do new things with it, so I don't ever feel stale or bored with teaching a CAD class. CAD being, of course, computer-aided design.
What's the best CAD software?
Oh,
you're right into that.
Right into it.
loaded question.
No, I think you need to use different things, different tools for different aspects. I'm teaching Onshape, which a lot of people have some mixed feelings on. For the class, it is absolutely the perfect solution for a class that I only get 50 minutes a week for lecture. And we have teamwork, and so I don't have to deal with installs. You don't ever have to worry about saving. And one of the great things on Onshape is it's collaborative. It's, quote, the Google Docs of CAD. Mm-hmm. So for that course, that is perfect software. If I'm teaching statics and I want to show something in CAD, Onshape's great for that too, because I can just share a link. You don't have to know anything about the software. You can open it up.
So for our viewers, Onshape is a cloud-based CAD software. So meaning it's independent of your computer. It doesn't run on, or most of it doesn't run on your computer. So you just need a web browser, and it's super easy to, any computer you can go and log into the same account. So that's why it's really flexible, especially for a class like this. You don't need to worry about installing, say, SolidWorks, which is what she was talking about.
Right. It also runs on iOS and Android. There's apps.
It's pretty nice.
And
Right.
It's very accessible.
Well, it's web-based, so
Right.
practically anything that runs a web browser will run Onshape.
Right.
So.
But yeah, Ben, you're a Mac user. I mean, I've tried using Fusion, and I think I even tried SolidWorks once on a Mac.
That's not a thing.
Yeah.
No, you can. Well, with the
Emulators.
Windows, with the emulation. Yeah. But how is that experience with even the best Macs these days? How is like Fusion or one of those types, or maybe Creo?
Yeah, so CAD is definitely not supported very widely on Macs at all.
Yeah, exactly.
So you can do Onshape because it's cloud-based. Fusion runs on Mac. SolidWorks does not. Creo does not.
Inventor doesn't.
Inventor does not.
So,
I think Siemens might.
Siemens. What is
because
that?
NX. Yeah.
What is it?
it's another
Siemens NX.
Siemens NX. I don't know that one. Well,
because I want to say that Apple either uses it or like it uses it in some capacity, so I believe that it runs on Mac. But point is, if you're doing CAD in industry, like you kind of need a PC, and I didn't want to do that because I like Mac OS and I like Apple products and I'm in the ecosystem, which is why I use Onshape as kind of like my quote unquote daily driver for CAD. But it's also why I had to build a PC for SolidWorks and Creo, because sometimes like you kind of do just need to run them, and with the new Macs, you can't just easily boot into Windows. It's not really supported anymore.
Yeah.
Wait, but Leipold, let's say you have a good PC and you want to work on a project by yourself, like a complicated project, maybe with a lot of components, a lot of like a big assembly. Are you still going to use Onshape?
Probably not.
Yeah.
I mean, there's some things like Onshape has done a great job with the part studios and multi-body modeling. So you're actually capturing design intent in the part building. Creo, I've always thought the assembly side of Creo is really fabulous. And you can do a lot of design intent in the assembly side.
Yeah.
When I switched to Onshape, the make connectors, where you're just going one point to one point, it felt like a cheat. It didn't feel like it was capturing the fact that I should align up one axis and another axis in a face, which is how you'd actually put parts together.
Yeah.
But the more you get used to anything, the more you appreciate it and want to go that way. So I love Onshape. Some of it's really their configurations.
Yeah.
Their variable studios, so nice and clean. But in Creo, when I teach advanced CAD, we do like a gyroscope, the little toy that you spin and it kind of wobbles.
Exactly.
We give it a speed, which I figured out by wrapping a string around 40 times and figured I pulled it in about 1 second. So 40 revolutions per second. That's how I got my speed estimate. And we apply gravity and you can watch it do the wobble in the analysis. And that's just not there in Onshape.
Is there going to be a yet to that statement?
Yet. There's not. That's not in Onshape yet. The model-based definition, so that is where we're trying to move away from paper drawings and get the key information onto the model itself.
That would be great.
It would be so great.
That would be so. I remember getting drawings and having to turn them into models just for a class last year, and it was just like, it was kind of exhausting. It's like, is this the best use of our time at this point?
Right. It's and there's so many parts that are made without a machinist turning knobs.
Yeah.
Like you're sending over G code,
Right.
or you're 3D printing in STL.
Yeah.
There's a lot captured in the model currently, so there's a lot of times we're not making a drawing.
Yeah.
It's still used a lot for inspection purposes, but a lot of that stuff can be done in model-based definition, which is where you're putting that information right onto the 3D model. Right. And Creo's done a really good job of that, and it's really just not available in Onshape yet.
I want to definitely touch on drawings a little bit later. I know that Leipold has opinions on that, especially sort of in the future. I had a comment on the assembly and connectors and things in Creo, or Creo versus Onshape.
Because you've used Creo.
I have a little of both.
At a
Kind of
internship, right? Or
Yeah. So the way that I think about assembling parts in Creo is, like you said, it's intuitive to how you would put it together, where any object has 6 degrees of freedom, right? It can translate in 3 different ways. It can rotate in 3 different ways. And one by one, you kind of constrain each of those degrees until it's maybe you can only slide in one, or maybe you can slide and rotate, right?
Right.
And so like it's very clear going from 6 degrees of freedom to only the degrees you want. It's very clear, like when you're removing those or when you're adding those constraints, it's very easy to make it do what you want, but it takes longer. And Onshape uses mate connectors, which I think of sort of like a shortcut for that, because you can capture. I think of assembling things in Creo as you're starting with full freedom and then you're narrowing down to constraining it to a certain thing. And I think of Onshape as the opposite, where things are totally free to move, and then you put a mate connector and it can constrain multiple things at once. So for example, in Creo, if you wanted to put two blocks together and you just wanted to, like, maybe they were different sizes, but you wanted to center the faces together and just have them completely fastened together, you might need to do a few different things. You need to constrain the planes. You need to do like maybe 3 or so different constraints. Where in Onshape, you click a face, and it just has that, I guess you can say, intuition, where it can assume like these are common ways that you might want to connect something. So it has that built in where you can just select those two faces, and it creates a make connector that constrains everything at once.
Yeah, it kind of makes like a center point, and then if you click that center point as opposed to like the entire plane of a side and then the center point of another one, it'll just connect those two together, and it won't allow it to like revolve or translate in any direction.
Right, and
with the relation.
And I think like what Onshape realized, and this is also the same way that Fusion works, is like if there are like repeatable ways that people are consistently joining things together, why not make that easier to get to quicker?
I want to jump on that.
Yeah.
So you said the word repeatable, and most of these CAD packages have a way to capture that. In Onshape, it's very clearly laid out as a make connector. So a lot of times when we're assembling things, we're using implicit make connectors, where it just offers you a buffet
Right.
of points that you may choose.
Right.
But it also has the ability to add explicit make connectors, where you define it. So as you were talking about the difference between Creo and Onshape with assembling blocks, I was totally picturing Legos. So if you want to put Legos together, if they're on the same level, right, you pick the inside face and those are coincident, and then you pick the outer faces, and those used to be called aligned. No, it's just another form of coincident. And then the top face, right? Or if you want to stack them, you could pick the bump on the top and the bump on the bottom and align those, and then use the side faces to align it, like parallel, and then the faces to make one stick to the top.
Right. So it's a lot of steps.
Right. In Onshape, you actually have to create a make connector, because if you're taking the top dot of a stud of a Lego, you're putting it into this negative space. So Onshape's implicit make connectors are fantastic for external features, but it's like this weird, like you're trying to make it tangent to all these other, the bottoms of the Legos, the little tubes, right? If you can picture the bottom, there's like a circle.
Yeah.
And you're trying to make your stud tangent to like 4 different sides of that. Well, that's a negative space. So you have to tell it, go ahead and put a make connector here so I can use it.
Interesting.
Which is, I think, cool. It's the other way you can think of it is if you see things like bolts or something, they always have a make connector. So you don't have to even go to try to find it. That explicit connector is a way of saying, I want you to always assemble to this thing, which is, you really want to take advantage of any of that stuff you're going to do over and over and over again.
Yeah.
So when you're making parts, you should really be thinking, how am I going to use this in assemblies? And yeah.
So what's the downside, do you think, to make connectors? Like, what's the advantage of doing it the Creo way or the SolidWorks way? If there is one.
I love make connectors. I use them more than just assembling. So the power of the make connector, and really it's just a coordinate system. So every CAD package has coordinate systems. Right. You could build coordinate systems into any part you wanted and kind of take that shortcut if you wanted. So with Creo, you can build these like connection sets, like not just a pin connection, but you can build these sets of constraints. And the other thing I do like or appreciate about Creo is that those connections live with the part, and they don't in Onshape. In Onshape, those connections just live as connections.
Oh, at the assembly level.
At the assembly level.
Yeah. Right.
Where I can go in and open up a part and edit that one and see all the ways that one part connects to other parts, where it doesn't show up like that in the feature list in Onshape.
So in Creo, if you have a part in an assembly and you have it, maybe like, let's say you have 2 blocks together and they're constrained in assembly together, do each of those individual parts share that common connection? Like, what does that look like?
In Creo, and this is kind of a good news, bad news thing. You can constrain to things that existed before it. So in a lot of CAD packages, just go ahead and throw all your parts in the assembly and then figure out where they go after. Onshape doesn't care what order you bring things in because things just exist between things.
Sure.
Creo, you got to start with whatever your base part is. That comes in first. And then things that build off of that come in next. And then, so they live under the part that they were defined in placement. So yeah, those connections in Creo only live at a part where they live separate in Onshape.
Well, I feel like
That kind of makes sense from like when you're assembling something together standpoint. Like, say you're assembling like a fighter jet, you're not going to like place all the bolts where they're going to go and then the plate that they're fixing. You're going to place the plate and then the bolts.
it's intuitive that you have to start with some sort of fix.
Sorry, I didn't mean to cut you off.
Yeah.
But there's a really interesting video that I saw that they talk about the difference between the CAD packages comes from why they were developed and the time that they were developed in.
Yep.
So Creo, before that was Windchill, before that was Pro Engineer, was developed as the first parametric CAD package. And so it's really developed based on that parametric kind of connection. So when you say intuitive, I grab right onto that because the way it does assemblies is because of how you're thinking about assembling parts. You're going to grab a part and put something onto something else. SolidWorks came in as the first big PC Windows-based CAD package, and they really tried to make one for the masses, and they've definitely succeeded in that. SolidWorks is hugely popular. Onshape was developed for a SaaS CAD package, a software as a service.
Okay.
Yeah.
And surprisingly, Onshape used to be a SolidWorks, or the John Hirschtick, who started SolidWorks, left SolidWorks to start Onshape because he knew that the future was
I didn't know that.
CAD in the cloud. So Onshape has started with the concept of collaboration. Right? That's why you want CAD in the cloud. There's no other reason to want CAD in the cloud. But the biggest thing, right, is the Google Docs of the world. The ability that we can all access it at the same place. We can decide how we're going to share it or not. What permissions to give people. So knowing that there was this need for simultaneous collaboration in CAD, that's how you can get the idea that these things are more based on capturing that design intent in the part and needing to make the assembly just as quick as possible because it's just showing how things fit together. The parts are what's the real important stuff. The assembly just shows how they fit together.
Yeah.
So when you think about why these CAD packages were developed, you kind of get a sense of why they have some of those aspects that separate them.
Yeah.
Right. But even in the more short term, until like laptops are more powerful, it is nice to have cloud-based computing just because you don't have to do all the processing right here. I know that's pretty nice. But
I remember
yeah.
one time working on my home computer, working on something. I thought it was really cool. I put it on my phone and showed my husband.
Yes.
And then I was like sitting in the stands at a swim meet, playing with it in my tablet.
Nice.
And then I picked it up at my work
So
computer.
you don't watch your kids swim at the swim?
Oh, have you ever been to a swim meet?
There's a lot of waiting.
There's a lot of waiting.
Yeah,
There's a lot of
imagine.
waiting.
There's so much waiting.
So, I mean, that's fantastic to be able to have an idea. And I'm not saying I can model up an entire thing on my phone,
Yeah, no.
but you can show it to someone, you can spin
That's
it
pretty nice.
around, you can change a dimension here or there.
I've used that before.
Absolutely.
Yeah.
And is it as fast? Like I used Onshape the other day. I don't use Onshape a lot. I usually use Fusion, which I get. People don't love that, I guess, anymore. But
Well, that's
I
also
don't know
cloud-based, so
Yeah.
it's similar.
Yeah, but you're processing locally. Like I just mean when I change something in that Onshape file, even on my desktop, which can do whatever the local side of Onshape is, my desktop is, or not desktop, my PC is certainly capable of doing, and yet it was still kind of slower than Fusion. Is that still an issue? Are they still getting faster about that? Or maybe was that my Wi-Fi? Like,
It could be Wi-Fi. There are some really interesting videos about how you can. Okay, Onshape does an amazing job with sketch patterns. Sketch patterns are not the fastest way to go.
okay.
So if you've got something that's symmetric and you can build a half and then mirror it, that's
Right.
faster. Like there's depending on how
course.
you're doing patterning, part patterning's faster than feature patterning.
Sure.
And they've got a great little clock that shows you, hey, if I do this
Yeah.
hole as a up to surface, it has to take more time to figure out where that surface is. If I set this hole as through all, it just keeps going and that's a lot
okay.
faster. So there's a lot of documented tricks as to how to make things faster.
Okay.
So it's not something I think about much in my class
Sure.
because most of the stuff we're doing is pretty, until we get to the whole chime machine, like most of the stuff doesn't get too,
Like the piston
Challenging.
project is very like low level, like intro to CAD.
yep.
So
That's nice though.
Yeah, what I was gonna say before about assemblies is I guess like in my mind, if you have parts in an assembly, it makes sense for the connections to belong to the assembly and not to the parts. Like maybe there's it's more convenient for it to be connected to a part like in Creo. But if I were just to like guess which one makes the most sense, I feel like a connection belongs to an assembly because usually you need more than one part or
Because it can go both ways.
Wait, can you click on a part and see everything it's assembled to, like the connections in there, or you can't even?
Yeah, you can.
you
There's
can? Well, then
there's a
that's-
nice little shortcut H
Yeah.
that'll show mates. So if I hover
That's
over
pretty
this
nice.
part, all the mates associated with that part will kind of highlight. They
Yeah.
have symbols. If you click on a part and say show mates, it'll list them in the feature tree.
Yeah. Okay. So that seems.
yeah. So in CAD, there's the concept of bottom up modeling and top down. So bottom up is you kind of sort of independently make your parts, then you throw them into an assembly and you connect them together. But top down is, you sort of build the parts together in an assembly and you define things in context with each other. What are the differences with that? Like, what does that workflow look like in Onshape and in Creo? Which one do you like better?
So Creo's got some really interesting things that we don't get to in an academic setting, but they've got skeletons. You can absolutely bring in like a sketch and copy those components out into other parts. You can do all of that like part building. You can do that right in an assembly. So if you open up an assembly in Creo, you can either bring in a part or you can create a part
Right.
there. But in Onshape, so after you guys have left, they added this thing called Rigid Studios.
Yes, I've been using that actually.
And it is fantastic. Yeah. So you're building parts, especially things that are not going to move. So if in the context of the chime machine, which we did in the big class, engineering design tools with machine shop and design and build and all that stuff, you have a structure, a static structure that there's no motion in that. And you can have lots of parts at different angles, and trying to assemble that would be really painful. And Onshape makes this very easy to do by just building it in the part studio. And when you bring it into the assembly, you bring it in rigid. So there's no motion on anything. It's all fully defined. And if you make any changes to the part studio, you add parts, you remove parts, you modify parts, they all completely update.
That's nice.
It's
is good.
really smart.
Yeah.
Because if you had to bring all those in and assemble them, it'd be a pain. There is a drawback.
Moving.
Are we supposed to guess what it is?
yeah.
The bill of materials.
Interesting.
Are you familiar with bill of
Yeah,
materials,
yeah.
right? So when you build stuff in a part studio, if you're building your chime machine, you're going to show all 4 legs that are all the same length,
Right.
right? You're not going
But now
to
you're building.
you're not going to build one and then assemble 4 of them.
Yeah.
Yeah.
Right? You're going to build your whole static structure. And so if you have a lot of duplicate parts, that does not show up in the bill of materials.
Oh.
Do you think that's like a bug, or do you think?
No, I don't know that there's a way to capture that yet.
So are you saying like, let's say you have a part studio and you have 4 legs that are maybe their own individual parts, but the same shape.
Exactly.
Will that show up as 4 individual parts or just one? And it can't rectify those as the same.
So I think if there's a tool called frames, so you can pick a cross section and tell it how to go, and they'll give you a cut list.
Yeah.
And I think that's one way to approach it, is it would list how many parts you need and
Yep.
what links to cut to. But yeah, I don't yet see a way to get into a bill of materials where you have identical parts that have different part names
Right.
captured.
Because when you, like in a part studio, if you were to mirror a part, it creates a new one. It's not really,
Correct.
once it's been mirrored, it's no longer linked, correct?
Right. Every geometry you make that has some gap between it and something else, or even if it doesn't have a gap and you tell it to be a different part, right? It's
Well, yeah, right,
it's
right.
tracked as its
Right.
own part. So one of the things I love about Onshape, and they're not paying me to say all this,
But by the way, Onshape, if you want to sponsor us, hit us up.
right on. And you probably know more about this than Ben. You probably know more about this than anyone I know. Is the feature scripting, and that is
loves
another reason
feature
I
scripting.
like Onshape over some other ones. Is it's open source to everybody to
Right.
make public documents that you can use. So maybe someone out there has found a way to identify things that have the same mass, the same moments
Yeah.
of inertia, the same anything that looks like a duck and
Sort
is
of
all-
in a roundabout way, go and figure out which parts are the same.
maybe
Yeah,
they can make a custom table
That
that
would make sense.
captures
Yeah.
parts with the same
I
characteristics.
think like maybe a long-term goal for Onshape to work on is instead of needing to have a sort of a roundabout way of doing it, figure out like if I'm maybe extruding 4 squares into 4 different posts, maybe capture that as these are
Yeah.
it's one extrude, they're all the same distance, these parts should be counted as the same. Or if I'm revolving a part into multiple things, it should be able to figure out these are supposed to be the same thing.
or an option to pull things
Right.
together.
But then
Yeah.
the problem is that now, since after this feature has been computed and these parts are no longer linked, now let's say you modify one of the parts, now that breaks. So it's tough.
Well, I'd want it to break. I wouldn't want to have a part different,
Well-
but still capture.
Yes, but maybe if they go with what I said earlier, and you do an extrude, you have 4 different things, and it captures it together, they need to now check if you ever modify a part, it needs to break that, which it should, but they need to make sure that it does. So there's some edge cases there that make it tough.
How many of you did First Robotics?
I did.
These guys.
Okay. They have some great feature scripts for Onshape for First.
Oh, nice.
You haven't seen them?
I mean, I actually brought CAD to my first robotics team. We were pretty old. I mean, that was like 3 years ago only, and they still didn't really even use CAD or 3D printing. And I was like, hey, I'm
You
pretty good at
revolutionized.
yeah, I'm pretty good at Fusion. Why don't we start doing this? And I did teach some people how to use Onshape. I had to learn Onshape to do that, and I actually don't know if they still use it, but I really hope they do.
Yeah.
Because just using CAD in general is really helpful for first. Just
Yeah.
being able to model
Yeah.
things. Like before then, they had their whole. My team, our robots were just on paper and pictures and diagrams. It was just not very helpful.
You and
So-
I had very different like.
Oh, my team
introductions to
was
first.
yeah.
Finian, what was your robot like?
So, shout out to Team 5804. So when I was first introduced to First, we had our mentor, the person that like runs the team for people that don't know about First. He already had started a couple teams, and for us, he was like, "Okay, this is how we're going to design. I'm just going to tell you how to go about designing. I'm not going to have any input in how the robots can end up." So he was essentially like, you're going to be using CAD. You're going to work together. We're going to have different teams that are focused on different portions of the robot. And then you're going to have to integrate all this together. And he was like, go have fun. So I had to learn Autodesk Inventor, which I know you're not the greatest fan of.
I have changed some of my views on that.
Okay. Fantastic.
So I mentored First, 2000, no, 90, I started in 96,
Okay.
mentoring Team 73.
Wow.
I'm 73.
2 digits.
Where is 73?
Here.
Oh, okay.
Yeah, I went to RIT for my undergrad.
Oh, okay.
Oh, wow.
Yep. So I did the engineering exploration program, and they tricked me. I picked mechanical because I didn't want to code, but that's a lie.
Yeah.
But my first Mech-E class I took was the materials processing class, which is now the machine shop portion of 104.
Right.
And as soon as I got into machine shop, I'm like, yep, this is where I need to be.
Yeah.
And I got involved with RIT had a pretty good group of college students mentoring Edison Tech downtown. And they also had mentors from Harris, which is now L3 Harris.
Yeah.
And it was great as a college student to have the ability to share with the younger students, but also to be able to get that experience from the engineers from industry and kind of be in that in-between section. Was great. When we were under quarters then, so we would come back right after New Year's, like
Yeah.
right when kickoff is.
Yeah.
Since RIT went to semesters, we had this big long break. And if you can't have people together for the first 3 weeks of build season,
Which
like
is
yeah,
only like, is
not
it
gonna work.
6 weeks or?
yeah,
Yeah,
it used to
about
be
6
just 6 weeks and 3 days.
And then they would be like, you can't make any more changes to your robot. Nowadays,
Bag and tag.
it's,
Wait, it used to be that way?
Yeah.
Wow,
Nowadays,
okay.
you can just continuously upgrade your robot as the
Wow.
season progresses.
My team would have like a barely functioning robot by first competition, and that between first and second and third, that's when our robot really came together. So that's
I thought you
unfortunate.
Yeah.
were going to say that's when it completely broke down.
Oh, well,
That too.
Yeah. I mean, like sometimes you need it to break to be like, why are we doing it like this? It would be
Yeah,
so much
that's true.
better if we just scrapped
I'm
this.
kind of well known for having the idea on our team's robot that gets thrown out first.
Oh,
So if we're using something I made, like I'm just waiting for it to fall apart.
hey, but the first idea kind of inspires other ideas. So you're getting the ball rolling.
Right.
Like that.
So the reason I was so anti-inventor is you couldn't have, well, I was using Pro Engineer, Wildfire, whatever, Creo at school. And then the biggest thing was sub-assemblies. There was no motion that transferred from sub-assemblies into assemblies. And I was so used to that in Creo.
Oh, you're
And it just would frustrate me to no end.
Yeah.
So now the frustration is just because I don't use it every day. That muscle memory stuff, right? I want to use my middle mouse to rotate the model, and you got to hold down shift
Right.
or whatever.
Yeah.
It's that kind of stuff. That's the biggest issue between any of these, is the things that become muscle memory.
Yeah. By the way, I think the only proper answer for mouse controls is right click drag to rotate, and middle mouse button click and drag to pan. I mean, that's just so easy. Does
So-
anybody have any comments on that?
I disagree. I think like left button select. So like
Well, I would-
obviously,
please.
obviously,
Yeah.
you didn't even mention that. So
Well,
obvious.
that was kind of a given.
And then I sort of see the middle button as like, oh, I want to move. I will use the middle button.
Yeah.
So I don't use the right button. So an inventor middle button click is pan.
Yeah.
Shift click is rotate.
Okay. I just
I think so.
Yeah, I'm more in the Creo universe. So middle click is rotate, but middle click is also enter, which that is better
Enter.
than, if you want to confirm something, you don't have to hit
okay.
enter. You don't have to hit enter. You,
You can
just
just do
middle
it right
click
there.
and you get out.
That's really nice,
that
actually. I've
is
never
nice.
thought of that.
You didn't know that?
it's been a while since I used Creo.
So the downside is you also use middle mouse to rotate. And so sometimes you're trying to rotate and you
click
click it instead of click and hold, and it gets you out
Yeah.
or it enters
Interesting.
before you're done.
Huh.
But
Interesting.
I just feel like if you can navigate the area without touching the keyboard, like if everything could be on the mouse, that's what I want to do, right?
Well,
Like,
one hand's already going to be on the keyboard. Like you're not,
Yeah.
when you're moving your mouse, you don't take your hand off the keyboard.
so I thought you were going to say the only answer is a space mouse.
Oh no, yeah.
I've tried to
I never
use-
used.
What's a space mouse?
It's real difficult to control when you're first learning it, but as soon as you get it down, it's like,
Is that one of those ones with all the buttons and the?
It's
So
like a
they
3D.
have some simple ones
Yeah.
that's just like a puck, and you can use it
Okay.
to rotate. tilt, and zoom.
Yeah.
That's interesting. Okay. Wait,
And
how does
then
that
your
work?
other your other mouse is for pointing and clicking on like the dimension or the tool that you want to use. So you use one mouse for
Interesting.
selecting
It's a two-hand
tools.
thing.
It's a two-handed thing.
And so there's no keyboard involved. And this
There
is
is for numbers and stuff like that.
Oh, okay. But
That just I
this
don't
is
like
really
the
interesting.
having to move back and forth between keyboard, mouse, I don't know, but I'd have to try it.
So some of the space mice, some of them have a bunch of. I have one that has like the top view, the front view, the isometric view.
Oh,
those
yeah.
are
Right.
those are
yeah.
buttons.
that's
Yeah.
nice.
And then there's like a button for sketch and extrude
Yeah,
and all that stuff.
I have.
It's taken me. I don't use it enough.
yeah.
We should talk about speed modeling.
Speed modeling as like a competition or just
Yeah.
trying to model quickly.
Yeah, but in a competitive sense.
I've always kind of thought about that actually, but never looked into it.
Well,
So that's a thing?
You run
do this?
speed
I-
modeling, or
I've tried. I don't have enough time. I really need to inspire a group of students to take it up and run with
Yeah.
it.
So is that something where like RIT could have a team that speed models and they compete against other schools? Is it that big?
It's more internet. It's
Okay,
more
yeah.
YouTube.
Yeah. yeah.
That I've seen most of it done by this guy, Too Tall Toby, and he's got a website
seen
and he's
him.
got a
Yeah.
YouTube channel, and they have these speed modeling competitions that you have to kind of like submit scores to get qualified for.
Okay.
And it's pick your package.
Interesting.
And so you'll have Onshape versus SolidWorks. And it's
Wait, but which one's the best? Which one? Like, there must be one platform that a lot of the best ones use, or is it not? Or is it Onshape? It's probably Onshape. Yeah.
really,
so
I would not have thought that.
I wouldn't have either.
Yeah.
So because Onshape is, very customizable, you can change your shortcuts.
To make it really quick.
And they've done some things like they have a custom table that's the Too Tall table, or Too Tall Toby's table. He uses 4 different materials,
Okay.
right? So you're not assigning a material to the part. You're just modeling it, and then you're looking on the table to say, if it were steel, this would be the mass. If it were aluminum, this would be the mass.
So is it a feature script, or
It's a table. It's a custom table. But you can access it through the feature script.
Wait, do you mean you're basically assigning material before you know which material you
You
want
don't
for
ever
that group?
assign it to the part. You just see based on the units and based on the volume.
Yeah.
You see a table with
Yeah.
all 4
That auto-
masses listed.
That auto updates.
It auto
so-
updates all the time.
Are those 4 masses given by the competition? Like how do these competitions run? Are you
Yeah.
given like build something that does this, or you're actually shown a part?
You're given
and
a drawing.
You're given a drawing, and you turn it, and with materials, I'm assuming.
Yep.
And so there's 4 materials that you can work from within that, or
Right. So he only uses these 4 materials because
Okay.
different CAD packages have slightly different mass
Sure, okay.
or densities.
yeah,
Like ABS, I don't even dare list numbers, but
Right.
like he lists the density of ABS as 1.02, but in
Right.
Creo it's 1.04.
Sure.
okay,
Like
pretty close though.
so they tell you ahead of time, these are the 4 possible materials we'll use. They just
Yeah.
added oak, which is very fascinating to me. Like
Interesting.
how you can assign a single density to oak
yeah,
Yeah.
is fascinating. But
okay?
so there's
Yeah.
a table with 4 materials,
Right.
and you don't have to assign one. You just say, I want this one.
yeah,
And so, yeah,
that's pretty cool.
he's got a website. You can create a free account, and you get access to these drawings. And you click go, and then when you have the mass, you just copy and paste it in. It says, "Hey, this is how
That's
long
pretty
it took
cool.
you. You're in the top 20% of speed modeling."
How complicated
pretty
are these
cool.
drawings?
They have different levels. They have level 1, which is just like a square with a little foot. They
And so
have-
is all the grading just done by the weight of the object at the end? Yeah. Okay. Yeah, I see. That's
So
pretty
it took
cool.
me forever to appreciate the value of speed modeling because I was so ingrained on design intent.
Yeah.
Like designing for the future, especially RIT has such a big co-op program
right.
that if you're there, and when I came through RIT, our co-ops were 3 months and we had to do 5 of them and we were on quarters. So, it was different.
Yeah.
But if you're only there for 3 months and you're working on something, like you gotta leave something, you gotta assume that that's gonna be changed.
Yeah.
Where I think in high school, a lot of that design is build this lamp
Yeah.
and submit it.
Sure.
You're not building for the long term. You're not picking features that kind of explain how this is going to work. Speed modeling's not like that.
Yeah.
I think I would be
Nothing's parametric.
I think I would be a horrible speed modeler because I love parametric design.
Yeah.
I love design intent, and I spend a really long time doing CAD because I think about if I need to change this variable, if I want to change this, how can I make everything infinitely parameterized and updating and not break things? And I think I wouldn't like speed modeling for that reason because I don't like doing something the quote unquote not proper way.
Lots of shortcuts.
Yeah.
Ben is the most meticulous person I probably know. Like
I take a long-
everything is detailed. Every detail. If there's a proper way to do it or a not proper way to do it, you always do it the
I
proper way.
spend a lot of
Yeah,
time doing things for that. Like I just like to do things very like calmly and in a proper fashion.
I try to find a balance.
Yeah.
I don't know. There's I like that though.
I have this like silly little model that I probably spent 4 hours on that should have taken 20 minutes, but I'm like,
Hey,
I
you
want
do
to do it
that,
this
though.
way. No,
Yes.
I want to be able to update this and change it and have
Oh, I
it
love
like
that.
so I get both sides of it. I'm hoping to include these drawings from the speed modeling a little more, just to like, okay, it's the middle of lab, right? Lab's 75 minutes. Sometimes those labs just feel like I need to stand up. I need to like, or I'm already behind. Like if they just keep going, like why am I even paying attention anymore? Because I'm so far behind, right? Yeah. So I'd like to try to break those up with, okay, speed modeling competition. You can join if you want. If you need help on what we've been doing previously, if you need to just get up and go use the bathroom,
Yeah,
like
that's cool.
here's a drawing. And I think we need more connecting drawing 2D to 3D. I think there's,
Yeah.
and when I first taught or mentored first,
Yeah.
we made so many more drawings because everything was like working through with our mentors on a Bridgeport or on a lathe. Like we were fabricating so many more parts in the 90s and early 2000s.
Like my team, we do fabricate parts, but we don't use drawings. So I was actually on like the manufacturing portion of the team, and we would design parts and then manufacture them on like a 3-axis CNC mill. So,
with G-code,
with G code. So we
right,
would
CAM.
never make drawings. We would just convert it to G code.
Right, and that's what I'm saying. I
immediately.
think we don't see the 2D to 3D. We don't need 2D as much. So I think there's a hard time, like you said, reading a drawing can be really
Yeah.
challenging if you don't have that real gut. I mean, when I came through RIT, we spent weeks doing hand drawings.
Right.
You know, and this visible line is going to show up in these 3 views, and it'll be a
Right.
hidden line here, and a line means a surface, and all of those. I think you get a better sense of how parts are when you can do all that. But it's just not as important anymore.
When I started as mechanical engineering tech last year. This year I switched to mechanical engineering, and that was a big part of our engineering tolerances class. We spent over a month doing what you were just talking about of here's a part from a drawing, go model the part from the drawing, and then go and make your own drawings of it and do all the things, show the hidden lines, show where all the screws are going to go, show where everything is. And it was really meticulous. It was actually part of the reason there was a bunch of reasons I switched to mechanical engineering. But just for anyone listening, RIT has an engineering program and an engineering technology program. And the engineering technology program is a lot more hands-on, or at least that's how it's kind of framed, is it's less theoretical, it's less kind of material science. It's more just actually, I just want to build stuff. And that was really appealing to me, but I ended up realizing I really like doing a lot more in-depth CAD and analysis of things. As a professor here, how do you feel about the difference between the two programs? I know you're in the mechanical engineering side, or engineering side.
Right. I think they're very similar.
Yeah.
A lot of people are surprised actually that there's a mechanical engineering and a mechanical engineering technology.
Yeah.
And we have a statics class and they have a statics
Right.
class. The biggest I've heard between those two is that we use calculus,
Right.
but how much we use calculus is very limited.
It's pretty small. Like
pretty
I'm
small.
taking UP2 right now, University Physics, which I heard horror stories about. It's not. We use almost no calculus, and I have friends in mechanical engineering tech. We're doing basically the same thing as them. So at this point, I don't. Yeah, it's interesting. I don't know. It's hard. It's hard to define what the actual differences are between the programs at this point.
I think maybe the difference is, I mean, obviously calculus is sort of the fundamentals of the math behind a lot of these classes, and maybe in the Mech-E classes, the professor will show you the proof, right? Because it's all coming from calculus, but there's assumptions that you can make that can, quote unquote, convert that calculus into algebra,
Right.
right? You're assuming certain things. Maybe, it stems from calculus, but at the end of the day, what you're really working with is mostly vectors and algebra.
Yeah.
You're not really doing like symbolic integrals super often, unless you're giving maybe you're given acceleration as a function of time, find velocity, whatever. But
Yeah.
So some of that stuff is driven by accreditation. So our department, our college, the Kate Gleason College of Engineering, is accredited by ABET. And there's a engineering colleges division of ABET, and there's a technology colleges division of ABET. So there are different requirements for an engineering program. So teaching statics, even if we could find centroids of squares and triangles and circles and use a table to find those, or to use Onshape, because they'll always put a centroid or a mate connector at the centroid.
That's nice.
We still have to introduce the area under the curve version of it,
Right.
because that's a portion of the ABET requirement.
interesting.
What is ABET? So
I
what
knew
is,
you were going to ask.
Yeah.
Accreditation Board of Engineering and Technology
Okay.
or something like that. It started as a U.S.-based one, but now it's definitely grown.
yeah.
Most engineering colleges or programs will be accredited.
Sure.
MIT is famously not, because they feel like
Hey, we're
you don't want
MIT.
it.
Yeah.
You don't want an accredited degree. Don't come here. Or
Yeah.
whatever.
they're smart enough to just they do their own thing.
Yeah.
But how much
We're
of the
MIT.
curriculum is built around what something like ABET would?
There's
want
so
us to-
many different things.
It's a
So
lot.
some of our curriculum is RIT
Yeah.
mandated. They're actually starting a 1.5 year evaluation of our general education requirements, which I think is
Interesting.
really beneficial.
Yeah.
Wait, RIT is?
Yes.
Or, okay.
So right now, 60 credits. So for mechanical engineering, you have to have 129 credits.
Yeah.
Yeah.
Something like that.
60 of those have to be general education,
Right.
which I think is a lot.
It is a lot.
That is almost half.
I'm sorry if Munson's listening. I'm sorry. I think for what we're paying for an engineering degree, to
Right.
have half of that mandated is not engineering. I understand the need for a well-rounded education.
Right.
It's pretty round, though. That's pretty round.
That's pretty round. Yeah. So some of it's RIT, some of it's middle states, some of it's New York State. So we might have different requirements
Right.
than Penn State, and then some of it's ABET. So there's a lot of
Do all these things compound? Like ABET's requiring you take a writing course, but New York doesn't require that, but they do require you to take an ethical course. And RIT doesn't require either of those things, but they do require you to take a social perspective. And then all these things compound to needing 60 of your 120
Right.
something credits.
Right. So, yeah. It's not all on us.
Yeah.
We have lots more we'd love to teach. So when I came through here, right, it was quarter system. So you got 3 quarters a year, 4 classes. So most of our classes would meet for 1 hour, 4 days a week. You got 12 classes every year. It was only 10 weeks, but it was pretty comparable in amount of time. But you're getting 12 classes a year instead of 10. And so you
Yeah.
got more variety of topics, I thought, under the quarter system. But you're only taking it 10 weeks. We called it drinking from a fire hose.
Yeah.
If you got injured, if you had mono, like, boom, quarter's done. Like, you're...
Yeah.
That's actually really
That's
funny.
pretty rough.
My AP stat teacher in high school compared like AP statistics to drinking from a fire hose. And that's the only other place I've ever heard that metaphor.
Yeah. I liked it. You get into something, and if you're in a class you don't like, you're out. You know, you get through it, 10 weeks, you're done.
Yeah.
Yeah. Do you know much about the decision to transfer to
It's funny you use the word transfer, because some of it had to do with trying to get transfer students in. That was really hard to make,
because a lot of other schools use it.
Most everyone else was on semesters.
Yeah,
so
semester.
if you're transferring in and you've got, Calc 1, are you getting credit for Calc A and B, or just A, even though you've gone through part of B?
Yeah.
We would have Calc A, B, and C. They'd have Calc 1, 2, or
Right.
Something like that. So it did become really challenging to, fight for both ways. Like, our students couldn't transfer. We couldn't get people to transfer in. It was really challenging to get all that stuff to work out.
Is that why we still have a Calc A, B, and C, and we have a Calc 1 and 2 now? Like, that was a little redundant.
So that's for, there's so...
Just people that like to learn at a different pace, maybe,
And maybe it's not like to learn. You picture different schools, and maybe you had an amazing physics teacher,
Right.
and you want to go home at break and you want to go visit that guy. Maybe you had an amazing experience. Not everyone is in that situation.
Right.
And so some people come in with less of a solid foundation,
totally. Yeah.
and it's not their fault. It's wherever their school district is. It's the resources that were available. It's the,
Yeah.
Yeah. Like, having a bad teacher can really spoil a subject for people. So,
yeah. For a while, I talk about my son a lot. His second grade teacher was retiring at the end of the year. She had total senioritis. His third grade teacher was pregnant and left it, November. He had a right out of college, like, long-term sub.
Yeah.
Fourth grade, we go to meet the teacher night, and my husband looks at me and is like, does she look pregnant? And I broke down in tears. I'm like,
Jesus.
I cannot believe it's happening again.
Yeah.
And then fourth grade ended up being COVID. So that's just,
Yeah.
but yeah, it was like year after year, like, when are we going to get a good teacher for this kid?
yeah.
So yeah, I heard a really great, it's a podcast on NPR, This American
Beyond
Life. This American Life, right?
Yeah.
And they talked about how when COVID happened, they dropped the SAT requirement for a lot of schools.
Yeah.
And that actually was hugely beneficial to a lot of students that didn't have a good schooling background. That, interestingly, SAT scores can be a better indication of wealth or opportunity
Yes.
than it is
actual skill or
actual
talent.
I could buy that.
assessment
That makes sense.
of
100%.
knowledge.
Yeah.
I don't like the SAT.
No.
Or I guess standardized tests in general. I think that it's very hard to quantify intelligence in any way, especially in the way that they do it.
Yeah.
If you have the resources to get a good tutor, if you study it's all a pattern, right? If you study the types of problems, you study the math, if you take it 3 or 4 times,
Yeah.
Versus if you have to have a 20-hour-a-week job
100%.
Exactly.
on top of school.
You can't do it.
Or you don't have a car and your parents have 3 jobs and no one
Yeah.
can get you to
Yeah.
the test. It's, on the other hand, right, going back to what I was talking about, like, if we just use averages from a school, like, that's really challenging to use too. Because different schools will have different rigor. I mean,
Right.
you do take the same, like, AP exams, but you might, anyway, you might have a teacher that wants to show you all this amazing stuff, and then another school might have one that just teaches to the test.
Yeah.
Right.
It's really hard.
No,
And so you get people that come in and they're, we're doing great in their high school, and they get here and they're like, I didn't get the knowledge I thought I was getting.
Right.
Yeah.
It's really a hard situation. Anyway, this American Life episode really talked about, it's really that first semester, and if there's a way that you can find those students that have that deficiency and help them fill it, that shouldn't last more than that first year. That after that, everyone kind of has the same sort of knowledge after that first year, that going beyond that, it should be normalized.
Interesting.
And do you think the solution is just having courses of different levels or paces, or like, what do you think?
I don't have a solution. I wish I did. So in the context of the class I teach with CAD, we get students coming in with 6 years of CAD experience, and some of them have done more impressive stuff than I have.
Yeah.
And I love seeing what they're doing, and they'll show me something they worked on. I'm like, I didn't know it could do that.
Yeah.
That's awesome. And some of them have never opened a CAD package.
Right.
Yeah.
And I have to teach them in the same pacing.
That,
the
Which
same
doesn't make any
class.
sense.
And so I try to say, here's the baseline homework, and here's some more stuff you can do with it. And everyone's been taught different ways. My son says I told him to not do little piecemeal steps. Like, the more stuff you can include in one sketch, the better.
Right.
I don't remember ever telling him that. I think it depends on the function.
Yeah.
That I think you should group things together that function together. But anyway, he got that in his head, so now he tries to do that. all the
Actually,
time.
I do the same thing, to be honest. But partly is I'm just obsessed with the timeline and Fusion.
Yeah.
So I love the parts
keeping
where I
it-
can change anything I want at any point, and it'll completely update. And so part of that, for simplicity, is I have a couple sketches that define everything, and I've always loved that.
Oh, yeah, that's a great.
Just organization strategy, just because
I'm a fan of skeleton sketches,
yeah.
for sure.
Yeah.
Sort of define like one, I call it like the master skeleton sketch,
Interesting.
and
No, I'm just picturing how we could do that with the piston. It could be interesting.
yeah.
it doesn't work
It's hard
for
to do.
every model, and
Yeah.
it also depends, like I said, on your workflow and whether or not you want to do top down versus bottom up. I like top down because you have a lot of flexibility, but sometimes it's hard. And I guess sort of going back to the whole Onshape versus Creo versus SolidWorks type of thing, I think it's interesting because they take a very, in my opinion, sort of fundamentally different approach to parametric CAD. So in other words, in something like Creo, and I haven't used SolidWorks, I'm starting to use SolidWorks. I think it's the same thing. Is you can make one part in a part file. You can't make more than one part in a part file. Is that not true?
It used to be. They are all
change it.
starting to copy. Yeah.
Oh, that's interesting.
And because Fusion, you can build multiple parts in a.
Yeah, you
right.
can.
So it's like a part studio.
Well, it's a part, but you can have multiple bodies. You might have multi-body modeling.
Yeah. Well,
Look into it. So I see that all the time, right? I know Creo and I know it can do this, and now I'm sitting down to Inventor. How do I do this thing in Creo? Then how do I do this in there? And there's
Right.
usually, if you know that something exists, there's usually a way to find how you can do that same sort of thing
right.
in another program.
Well, okay, so you can do multi-body modeling, but is that not considered one part in Creo?
In Creo, you can take a body and you can make a part from a body.
Okay. So it seems like sort of a workaround way. Yeah.
Yeah. Which is why I tell everyone I think Onshape and Fusion are modern CAD because they don't have that history. Like Creo was made in the 80s. Like
Right.
everything they're doing was made in the 19th century or 20th century. Sorry, 1900s.
Yeah.
So multi-body modeling, Creo Plus, which is Creo that has a cloud version.
Which is not Windchill? It's a separate thing?
No,
or?
Windchill is product lifecycle management. It's how
Right.
you keep track of the files.
Okay.
But Creo Plus actually allows you and I to be in the same assembly, but not the same part.
Interesting.
So we can both be in the same assembly, and you can be pulling in this part, and I can pull in this part, and
Okay.
that'll work. And you have to, it's harder to set up. So they're trying to pull that aspects. They
Well-
all try to copy each other,
Well, I mean, the same company owns both
Exactly.
Onshape and Creo.
which I think is why Onshape has gone so fast, so fast, is you've got all of
Yeah.
these
Yeah.
Creo engineers.
Makes sense.
The one thing they don't have yet, which is why our first team hasn't gone to Onshape, is
Yeah.
CAM.
yeah.
Yeah, Fusion is like the gold standard for CAM,
Absolutely.
pretty
Yeah.
much.
Yeah.
Is Mastercam still like I feel like
think
that?
so.
or-
Anything that was big once upon a time, there's definitely still companies
Yeah.
out there using
Yeah.
it. There's definitely legacy.
yeah.
Contracts.
Well, like just
No,
that
not contract.
that in a unwillingness to change.
Yeah, which that could lead us down many different conversations from here.
Yeah.
Just by the way, for the viewer, CAM is computer aided manufacturing. So CAD is where you design the parts and the assemblies and all these things, but CAM is where you actually describe how that's going to be manufactured on like a CNC computer numeric controlled mill or lathe, and you actually you define tool paths. So you define like how things will be cut, or maybe you're 3D printing how things will be built, sliced. So I want to see a lot more autonomy in CAM. I think that so for example, 3D printer slicers are really good. You design a part, you put in a slicer, you put some parameters, and then it automatically generates code for a 3D printer that'll generate that or build that model layer by layer. I want to see that same just simplicity in CAM for CNC for subtractive manufacturing.
Yeah.
But do you think that's anywhere close?
So, I mean, I know they're developing CAM in the cloud for Onshape. It's been, they told us we'd have it in 2023.
Ooh.
So, I mean, it's tough.
Yeah.
Yeah, as you said, Fusion's like the
Yeah.
gold standard, but we're doing it in Inventor. I don't want to say, oh my gosh, this Onshape assembly is so perfect. That's where I need to be. But then every time I'm like, oh, nope, that's the wrong diameter hole. I need to export my part again, bring it in, set up new tool paths.
That's annoying.
So because the communication between the design studio and the CAM are internal,
Yeah.
if I change my
Yes,
drill
yes.
diameter, all I have to do is
You need to be sure when you're going to like
Yeah.
make
But-
your CAM pathing that the part is what you actually want to be
Yeah.
manufacturing.
So, being a parametric person, there's really awesome tools now that aren't parametric. So, like, it's called Freestyle modeling in Creo. So, I have this beautiful little RIT rocket that was 3D printed for when we did the brand identity change. We went from orange and brown to orange and black, RIT with the dots to RIT without the dots.
Much
like,
better.
I definitely like black better than brown.
Yeah.
But we had all these little 3D printed rockets, and they said RET on them, and they had 3 fins on the bottom. So I can take that step file into Creo. Step file. So step files have no features, right?
Right.
It's just a body.
Yep.
And I can do pattern recognition on the fin. I can highlight the fin and say recognize patterns and change it from 3 to 5.
That's pretty
good.
cool.
And Onshape has a lot
nice.
of that stuff too. I'm assuming Fusion and SolidWorks have some of that stuff, but they have these not even surfacing, but just like direct modeling where you're not editing an existing feature. You're just taking a body and say, move this.
Yeah, I don't like
no
that.
idea.
I don't like it.
I know.
Like it's,
no idea you
it's
could do
fun.
that. That's cool.
super cool.
It is super
No,
cool.
I-
That's super cool.
There's so many.
I think that's cool.
It's
So, step files, right? Especially with first, you have
Yeah,
these
yeah.
swerve drives, you have these
Right.
like elevator mechanisms, right? You download the step files for these parts so that you can build them into your assembly.
Yeah.
But I can make that part with 3D printing, and I can make it myself. Why am I going to pay that company? But I just downloaded their design. So how's that make you feel?
Right.
oh interesting.
Right?
A lot of the time with like these like complex step files, you can't actually like manufacture the parts. Like yes, for like
True.
for the elevators, you 100% can for some of these things. Like you can 3D print the brackets, reinforce, and you don't have to buy the elevator from them. But if you're talking about swerve modules, that's an entirely different ballgame.
Absolutely.
And my team tried to like manufacture it. We took it upon ourselves, like, okay, we're gonna like buy the stock, we're gonna try and do all of this. It did not end out working well.
All of these companies that have built up around First have some really elegant solutions to like gearbox, 90-degree right angle, like hex shaft
Witchcraft.
spin. It's
Witchcraft.
It's incredible.
It's really cool.
But I kind of got into it. I have this assembly we used to do in advanced CAD. It's just this trolley thing, and there'd be a bearing in it, and the base part was 9 inches high, and my printer couldn't print it, so I made everything half scale just to show people like what are we doing. We can't get a half scale bearing. Like it just you can't go buy a half scale 1032.
Right.
Like
Sure.
stock fasteners don't scale.
Right.
So I'm like, all right, McMaster, let me grab your bearing file and print it half size.
Yeah.
And I could, because of those direct modeling features, I could, the 12 balls in the ball bearing, like
Scale it down a little bit, or
well, the ball bearing itself comes in as a part.
Right.
It's an assembly, but it comes in as a part.
sure.
Yeah.
But when I printed it with the 12 little spheres, they spread out too far and the whole thing shifted and they all fell out. I'm like, I'm going to try 15 instead of 12. Pattern select, 15, print, there we go.
Yeah.
Well, that's why some bearings have the like spacers in between.
Yeah.
Like I notice that sometimes when
That actually
assembling
makes it
stuff.
harder for me to print. But
Yeah.
is there an issue with that? Is there a problem
Like
with
an
me
ethical
taking
issue.
Yes, of me taking a step file provided by a company. I bought nothing from them. They don't
Well,
have the size I need.
I think that when they give the file out for without a paywall, then is that just them?
Yeah, I've never
giving it
seen
out?
like on McMaster. I agree to only use this for planning purchase. Like I've
Right.
never seen that.
Yeah.
But you know why they make it so easily accessible is because if you've downloaded that file and you've used it to build your thing, aren't you more likely to buy that
order
thing
one of
from
the
them?
Very true.
Or am I more likely to
interesting.
buy a ball bearing from McMaster because I can just take the file versus some mom and pop store down the street that doesn't have that capability?
Right. Well, I think they're probably not very worried. Like the percentage of people who are taking their files and going and manufacturing themselves, I think, is probably small
I agree.
compared to their overall clientele, I guess.
And I've always seen McMaster as kind of a prototyping like website. Like I don't know, I think their prices are bigger than like if you're gonna use a lot of their parts for something you're making a ton of, you're not gonna get them at McMaster prices.
Or you're getting
fair.
them
Like
or you're getting a
McMaster,
bulk
Yeah,
deal.
like
yeah,
at
you're
a
getting
certain-
them like direct manufacturers at that point. You're
Yeah.
not,
Sure.
We used them a lot previously on First because
yeah, it's perfect for first.
you had one, the team lead logged in
Yeah.
and you just went in and did add to cart.
right.
Yep.
And then at the end of the day, they'd place an order and
Yeah.
Get to you the next day.
get all the stuff you needed. Yeah, I hear what you're saying, like smaller, not manufacturing build.
Yeah.
But yeah, companies that'll make their files available to you, you're more likely to purchase
Yeah.
from them
I think that's true.
if you can just put their file into your design.
Well, I
That's
think
huge.
also what it is like maybe you have an existing design, you want to retrofit something, or you want to get some part from McMaster, put it in. You want to bring that step file into your existing assembly to make sure. So maybe they just want to allow you to visualize their part in your thing so you could buy it. But yeah, like I said, I think that probably out of everybody who downloads their step files, I think that like only a few % are actually. I don't think they're worried about losing money from it.
Right.
Yeah, so it's probably
But
fine.
maybe I don't know if they're worried about like if their feelings get hurt. I don't know.
Well,
No, it's a really interesting conversation. Where the value is, and what's okay.
Yeah.
I don't know.
I don't have the answers.
Yeah, no,
Yeah, it is a balancing act between like for our team we would go and like take the step files, incorporate them into designs, and we would like we wouldn't always buy from McMaster, but we knew that McMaster was a reliable source of models. So if we had a bunch of like random bolts, like 1032s in the shop,
a standard part like
Yeah.
that's also they're not. I mean, who like designed that part?
Right.
If it's a standard bolt or a standard.
But
you know.
I'm going to go on a ledge and say you should never be downloading 1032s from McMaster. Every CAD package has a fastener library that doesn't have threads and knurling and all of that stuff that can slow down. If you want to make it longer, you just switch to a different instance. You don't go download a different file, import it.
Yeah. As like an example, we knew that if there's some like standardized part that's not typically in any CAD package, and we're like, oh, we just want to make sure tolerances fit. We want to make sure that all of this is going to work before we pull the trigger and buy it. And maybe we found it from a different place that's cheaper, but they're not.
Amazon.
Yeah, maybe, but they're not.
AliExpress.
Yeah, but they're not going to provide a CAD
No,
model.
I'm agreeing with you. I've done the same thing.
Yeah.
No, I think this kind of falls under what Liam was saying, that they're not making their money off of a first team, right?
No.
They're more targeted at companies and
Well, and even the aspect that like that taking one of their parts and 3D printing it, that you couldn't do that like long term as much. And if you are manufacturing one of their parts, that means you're looking long term. You're probably not going to be buying a lot of their parts anyway for that project. Like my understanding, like especially with the way their prices are, they're really just for you're trying to make something quick in a prototype. And from that standpoint, you don't have time to manufacture their stuff anyway.
Maybe, but I mean, I've seen them on like bombs of legit.
Is that true?
Yeah. They're definitely used.
Maybe a
in the industry
misunderstanding.
but
the
depends.
defense industry can afford them, but
As soon as you get to like a certain level of manufacturing, you're going to start either doing stuff in-house because it's cheaper to just buy stock and then convert it all, or you're going to be, like as Liam said, buying straight from whoever is manufacturing these bolts, because McMaster is just aggregating it all and then sending it out. I don't think they're the ones actually like manufacturing all of these.
Probably depends on the part.
true. I think they do
like,
some, but yeah.
But I never received something from them and it's like McMaster like on the part itself.
gotcha.
Right.
It's all blank.
Sure.
So
A little bit of a pivot here. Oh, there's a lot of different paths I'm thinking about going down. What I wanted to say before with drawings is that I just feel like there's a fundamental flaw. Right? Once we started designing things in 3D in CAD, right? Because at a certain point we were drawing things on paper, but once we started doing stuff in CAD, we're bringing the 3D into 2D to bring it back into 3D. I think that like fundamentally there's either going to be a loss in quality or a loss in time when you translate between those different dimensions. And I just think that at this point I just don't see a good reason for it to continue. It served its purpose when you couldn't visualize it well, but I just don't see an excuse why we can't enforce that or so what do you think?
Oh, absolutely. So ASME is the Standards Institute, and they have Y14.5, which is their dimensioning and tolerancing GD&T like standard, most used standard of theirs in the world. They came up with Y14.41, I want to say 92, and that's all on model-based definition. And so they have a standard that was created 30 years ago.
Yeah. And
About how to create and interpret model-based definitioning, where you have the key dimension shown on the model, and then you just interrogate the model for the other dimensions that are needed.
Mm-hmm. Meaning like you would have, maybe you have a monitor and you'd have the part in 3D and like visually as you rotate around the model, you can sort of see like call outs almost like So if you had an isometric view,
You'd have things that came out in the front plane, but sticking off a surface on the right side.
Yeah.
And you'd have, things in the top plane.
Right.
And you can actually put those annotations on those planes. It'll rotate around with the part.
Yeah, that's neat.
Creo's done a really good job. It's hard. GD&T can be hard to show consistently. They have a really cool GTOL advisor. And so when you say this part is flat here, it'll highlight that surface as green, as in that has been toleranced, and everything else is still blue. And then you position this hole, and that turns green. So you know what
nice.
you've covered and how you've captured the form tolerances of individual surfaces. So Creo's doing a great job. Industry is so far behind. And some of it's inspection, like the aviation inspection group, like they have a certain style drawing that needs to be inspected, and that is how things get certified. So when you have those processes, like some of that stuff holds things up.
Yeah.
I've heard that one of the reasons we're not metric is because of the mills and the lathes that made parts and are so expensive, and they're set to inches. And that is, so technically we are metric. Like officially,
Like
the
as
US,
the United States.
the United States is metric
Isn't that
officially.
fascinating?
I didn't know that.
I mean,
And we have
Yeah.
been since the 60s or 70s.
wow.
But there's no stick or carrot. There's no
no way
punishment
to
for
do it.
not, and there's
Yeah.
no incentive
Yeah.
for.
Yeah.
Yeah.
So like the actual machining tooling is part of what's held us back.
Interesting.
Can't
But
you just
yeah,
put, like, a new
and
ruler
all of
on there?
those, right?
Yeah.
I think we're going to be in a world of hurt eventually when a generation of machinists and tool makers are not being filled from new generations.
Yeah.
I mean, but
We need more Mech-E techs.
so
Well, or we need more people that go to trade schools.
True.
Yeah.
Well, but machines are going to do a lot of that stuff too,
That's
which is
true.
interesting. That's
That's true. That's
that
a higher.
should fill some of the gap there. But you think the gap is going to be bigger than
I think there's still a big gap.
yeah,
Yeah.
bigger than it'll be filled. Yeah, I wonder.
So, like, do you think there's something fundamentally better or worse with metric versus U.S. customary, or is the important thing just being the same?
I mean, metric makes so much more
No,
sense.
metric's way better.
No, I
even
mean, I was
Except
just-
for, I heard that one of the things in the Cold War that gave us an advantage was that Fahrenheit is a smaller measurement compared to Celsius. So if you're
Right.
designing things in Celsius, you have this bigger range. You don't have the
Okay.
indications are
Yeah.
like you can get better analysis in Fahrenheit
Sure.
than you can in Celsius.
Interesting.
Just
That's,
because
well,
it's-
that's one advantage. I
Or
guess.
that's what someone told me.
one advantage against probably 100 drawbacks.
I
I
mean,
don't know. I'm not.
Have you guys seen the Saturday Night Live Washington?
Oh, yeah.
That's great.
I mean,
that's
that,
great.
that captured it's all right there. Like none of
Yeah.
it makes any sense.
right,
yeah,
right.
it's. Yeah, I don't know. I just find it a lot slower. Like I use metric always whenever I can. I mean,
Yeah.
a lot of that's because I grew up 3D modeling, and that just always made more sense metric.
And
Like
like
3D
slicers are
Yeah, everything-
and 3D
Yeah.
printers.
3D printing is
yeah.
automatically metric, so I mean,
it doesn't have to, but
yeah,
it is.
but it is.
Yeah.
So
Yeah, when I do speed modeling, I have two start parts. I have a metric start part and an English start part, so I don't have to worry about
Oh, like
units.
yeah.
wait, you were looking at both
No,
at
no,
once?
like,
What do you
like a
mean?
template to open it up.
Right.
That's what start part is.
So
Okay, yeah.
with the two tall Toby,
Yeah.
you know whether it's going to ask you in grams or in pounds.
Yeah.
So there's like this little thing, and so I'm like, oh, okay, I got to open up my metric start part
Yeah.
before I even
Yeah.
click show me the drawing.
Yeah. Okay.
By the way,
Oh.
I can't stand pounds versus like pounds mass,
Oh,
pounds force,
oh,
my
slugs.
goodness.
You wanna
Dude.
you wanna measure mass in U.S. That's a slug.
Yeah.
I mean, it's just. Do you find, because I know you talk about this in statics, is that really confusing for a lot of students, or?
Yeah, it is. And it can be really frustrating sometimes. I definitely see some students that think units are unnecessary or that think they can keep track of them in their head.
Yeah.
It's sad when you see someone take a pounds measurement and multiply it by 9.8.
Yeah.
Like even if you're confused about pound mass, pound force, whatever, it wouldn't be 9.8. Like that's meters per second squared. So units are your friends. Like when you're doing any calculation, if you are detail oriented about always writing down your units, like that is a big hint
Huge. It's
if you're
helpful.
on the right path or not.
I love like dimensional analysis and things canceling. Oh, it's just so
No, it is
satisfying.
nice, but that's annoying though.
No, totally agree. I'm right there.
Oh, it's great.
I'm so lazy about that. I'll use
I know.
ChatGPT to convert my units. That's which I know probably a lot of students do, but
So are you familiar with the Fundamentals of Engineering exam?
No.
FE exam?
Yeah.
So
No.
how about professional engineering license?
Yes.
I'm not.
So a PE is necessary if you're going to have your own company.
Okay.
If you're going to, a lot of civil engineers need to have a PE. If you're doing any consulting, like this professional engineering licensure can be helpful in some situations. It's not hugely needed in mechanical engineering. Most people don't get it. But in order to get a professional engineering license, you have to have had a fundamentals of engineering, which would make you an EIT, which is an engineer in training.
Wait, to have an engineering company, you need to have this license? Like to even start one or to run one? Or is it
There
to work
should
for
be-
certain companies?
Every company that's doing engineering should have a professional engineer employed.
Do you mean legally or should? Like,
I'm not putting myself legally into
no,
answering that question.
Oh, sure, no.
I'm not certain.
no, I shouldn't know if you meant like, is it actually like a regulation that you have to that? But because that's interesting. I've never
Probably.
heard that. Yeah, okay.
Probably. The FE exam is something you can take after 4 years of college.
Okay.
It covers statics, strengths, dynamics, thermo, heat, economics, ethics, control systems, all that stuff. There is there's a 250-page book of equations.
Wow.
It
Do you
is,
get that for the exam?
yeah. Yeah, they give it to you.
Jeez.
So once upon a
Half time
time,
is just looking up the right equation.
I love it. I have one at home, or I have one in my office. I have the PDF available. Like everything's there. Once upon a time, I thought it'd be a really good idea for everyone to have one of these, and then that's your reference when you go to take a statics exam, a thermo exam, a dynamics exam.
Oh,
You just
interesting.
take your
That's a
handbook
cool
of
idea.
equations. Well, so coming back to the ethics of things, right? How do I know you're not going to write other stuff in your book?
Yeah.
Or program your calculator. Or
Well,
And
that
so-
definitely happens.
So people, some faculty just couldn't get past that idea of I can't control that book,
Yeah.
which is, it's another touchy situation. Anyway, so for the professional engineers exam, you can bring in more stuff. Like you bring in your own resources if you want, but they ask a lot of stuff. So you better know where your stuff is.
Right.
And one of the things they have is that you can buy is like a 40-page book of engineering unit conversions.
Oh, wow.
And so
You bet.
It's back
you can look up your engineering unit and it'll show all the different things that can convert into and
Yeah.
just the multiplication. So it's not doing the whole factor label method.
Right.
Sure.
It's just a number.
Yeah.
But can you even
No,
40-page
that's-
book
a
of
40 page is
unit
ridiculous.
conversions?
So it's like pounds.
lot.
Oh, I want to convert pounds to what would be like a real
Newtons,
Yeah,
kilograms.
Newtons. It'll be like, oh, you're just gonna multiply it by
this. But it has even crazier ones. Come by, I'll show you sometime.
Right. I mean, because
Yeah.
all it is just a bunch of steps of dimensional analysis combined into one because it's just multiplication factors.
right.
Yeah.
But I guess that wouldn't necessarily work for things that have different scales like Fahrenheit and Celsius where there's an offset between them, right? Because there's not just a number you can multiply to get from one to the
It
other.
would give the whole equation
Okay.
of how you would get there.
Yeah.
Doesn't it bother you when people say it's twice as hot as it was yesterday?
Yeah.
a little.
Twice as hot and
What do you mean?
Well, if it was 30 degrees yesterday and today it's 60, Like 60 is not
right.
twice
Oh, sure.
Right,
the thermal load
Sure.
Yeah.
of 30.
It's
I don't think
like,
that bothers me, but
No.
maybe it bothers
it's like
you.
the whole thing about like, like 32 times 2 is 64. So I'm talking about 32 degrees Fahrenheit, but 0 degrees Celsius, if you're doing double,
Right.
it would still technically be 0 degrees Celsius. But
Because they don't have the same zero.
exactly.
Yeah.
So
It's the same. Well, it's also similar to the heat example is like something that sounds twice as loud is not twice the decibel value.
Yeah,
It's
exactly.
logarithmic.
yeah, it's only 3 decibels, I think. Something like that.
But anyway. Go ahead.
So for a Beyond
Yeah.
ME podcast, we have been very ME.
We have.
Yes.
Yes. This is one of probably our most
Yeah,
ME
yeah.
episode ever.
On my way here, I was thinking, we're beyond me. This episode's gonna be very ME.
Mm-hmm.
Maybe episode 12 is where but we can go beyond ME here.
Yeah.
Well, I was gonna ask Leipold
An
about.
ME question.
No, I was just gonna ask you about more about your background. And so you went to RIT.
I did.
What did you become a professor right away? Did you go into the industry? What did you?
I have an interesting path.
Okay.
So I graduated,
Yeah.
and I graduated with my bachelor's. They did have the dual degree program. At that time, I think there was more companies paying for graduate degrees.
Okay.
So I was kind of like, well, if I need it, they'll pay for it.
Sure.
And when you do the dual degree program at RIT, you give up a co-op. I didn't want to give up a co-op. I wanted co-op experiences. I probably had one of the more interesting co-op experiences just in that I did 5 blocks at 5 companies.
Yeah.
Interesting.
So like now we,
Do a lot of people stay? At a company more?
even
Yeah,
then
okay.
a lot of people would do back to back at
Sure.
double blocks.
Right.
So all of my companies had something to do with plastics. I took whatever plastics classes I could here.
So is plastics, is that your special other than CAD, I guess, or back? I don't know.
Yeah,
Then?
it's interesting that everything I learned about design, like how to design parts, flew right out the window with 3D printing.
Yeah.
And with some of the CNC, like subtract anything additive, like
Right.
blows away
Totally.
all the old rules of manufacturing.
Right.
It's fascinating.
You can do anything you want, basically.
Like those little infinity fidget cubes,
Right.
like
Yeah.
with it built-in hinges, just so awesome.
So
Right.
cool.
So cool. So I graduated. I went to Pactiv, still here kind of locally. They made the Hefty brand, anything Hefty brand. But I was in a different side of the company. I designed foam takeout containers,
Okay.
which are now illegal in New York State. We can't have foam packaging anymore. But one of my designs that I have a patent on from
Yeah.
that job won an award in the US and it won an award in Canada. So I used to have a sticker on my door that I'm an international award-winning inventor of illegal garbage. I don't
That's
think
pretty
many
good.
people can say that.
That's
Yeah, so foam takeout containers, trying to come up with different ways. I loved going to companies to see like what they can actually do. Because I'd have engineers say, oh, well, we can't do this. And I'm like, are you sure we can't? Like,
yeah.
maybe we can. Maybe we don't know what they can do. Like, let's go try to do, let's see what they tell us if they can do it or
Yeah.
not.
Yeah.
So I was there for 3 years, and then plastics tied in with oil and gas. So there was
Right.
a recession, and there was a company-wide layoff, and
Interesting.
I was laid off. I was still in the area. One of the engineers I worked with went to Temple with one of my professors, and they knew I was in town when there was a faculty member going on maternity leave, and I got a job here as an adjunct because someone knew I was available and looking.
Yeah.
When I was in college, I hated it's about who you know
Yeah.
Yeah.
because I didn't know anyone.
Yeah.
Right.
It's true. yeah.
So because I, serendipity and I landed here, I try to pay that forward. I try to help make connections. I love using LinkedIn for just like keeping track of people. And
Yeah.
Yeah.
when I meet with my advisees, a lot of them don't give it enough credit. If there was something more modern, I would jump. But I don't think there's anything that's really replaced that networking side of
Yeah.
LinkedIn.
Yeah.
But if you're looking for a co-op in Boston, right, and you do like the second degree people, you can say, who do I know that knows someone in Boston?
Yeah.
And
Networking
Professor
that way.
Leipold, she knows someone that works at iRobot. That sounds really cool. Maybe
Yeah.
she could help me get in touch with them.
Yeah.
So that's one of the things that I like using through there.
Yeah, that's great.
So yeah, I came in as an adjunct. I was 3 years out of getting my bachelor's. So I was
Yeah.
20. It was actually just 20 years ago this week that I came in as an adjunct. How old am I? So I was 26. I had some students that were older than me.
Yeah.
I was so excited when I turned 30 just to be a different decade than my students.
Yeah.
Not many people are like, yes, I'm 30. I was very excited about that.
Yeah.
But you can't teach with a bachelor's. So they said, we really like you. Why don't you keep teaching and you can get your master's while you're here.
Yeah.
So I got I'm very, very thankful
That's awesome.
to have had that path.
And how was that shift going from the commercial side of things to teaching? Like, did you have teaching before then? Like, or any interest in it, or
I had done the first robotics mentoring.
right? So that
My mom was a fourth grade teacher, so I swore I was never going to be a teacher.
right.
But no, I think they needed someone. I mean, sometimes I was learning that software hours before I was teaching it.
Yeah.
It's not the best way to go about things.
Mm.
But, if you have a question and I don't know it, let me search with you. We'll figure it out.
Mm-hmm.
Right.
And I think, some faculty members, like, really hold on to being the smartest one in the room.
Yeah.
That's not me.
Yeah.
I love the fact that we get some really smart students through here and what they bring and what they share, and we can't know everything.
Yeah.
Like,
Exactly.
we got to be able to change and learn and grow and accept that our way's not the only way.
Yeah. Right.
So, yeah, that's what got me here. I liked when I was in industry. Again, foam takeout containers, not really exciting. Oh, that's my other joke. I grew up, or I had a job designing foam takeout containers, like every little girl dreams.
Right.
Because everything has an engineer. Like, engineers touch everything.
They do.
Yeah.
You look at that to-go container that you're throwing out, you have no idea how many people went into the design and manufacture
Yeah.
of that.
Yeah.
And not only just the design, like, as a designer, you come up with like, oh, I want this tab here. And I don't know if you've ever gotten the containers that have like the little
Right.
cutouts, like for punch-ins to
Yeah,
let the, that's one of mine.
Yeah. Okay.
I sat through so much testing of fried fish. Like, we'd put them in there and we'd let them sit, and then we'd have to eat them to see how soggy they got.
Oh wow.
I was like so turned off of fried fish for like
jeez.
That sounds
years.
Brutal.
Yeah.
That's interesting.
Why fish? Like,
There was some company that wanted a container that wouldn't go as like soggy. So they were one of our
Interesting.
customers.
could you not find an alternative for fish? Like,
Oh, like to test that wasn't
Yeah.
fish? Like
Yeah.
chicken
You
fingers?
gotta test the real thing.
Yeah,
They had
I don't
fish.
know.
They
That
It
wanted
was like
fish.
the oils or something about
Yeah.
it that they
Maybe.
wanted to.
And French fries, like, you wanted to see how long it would take to get soggy. So we had to
yeah.
eat this.
That makes sense.
Yeah.
And be like,
crazy.
oh, it's not quite soggy yet, but it's getting pretty bad.
Yeah, this is a 2 out of 7 on crispness. Yeah.
Also, like how long it would take oil to propagate through it and see if it would like land on the bottom or something like that.
Through the fish or through the container?
Through the container, because sometimes like we'll get something from somewhere on campus. Well, I guess those are paper. Like
Yeah,
the-
you don't have
yeah.
any foam in here anymore. Yeah.
It's illegal. Illegal garbage.
In New York State.
in
New York
In
State.
New York State. And some of the stuff we were doing was like a little higher end foam that had like a solid laminate.
The good foam.
The
Yeah.
good foam.
Yeah.
One of my favorite things there, we had like other customers that would need different size stuff, and I called them prototapes. So you would just take
Prototapes.
old containers of different sizes and cut them up and try to put them back together
That's
and
fun.
see how they would go.
It's fun.
So I think there's a lot you can do with like trying to put it together with a X-Acto knife.
Yeah.
That's fun.
So yeah, instead of prototypes, I did a lot of prototapes.
Prototapes.
So I'm interested. I know that you're very like technologically savvy. You like to sort of, at least I think you like to incorporate sort of like new technology into your courses. What types of technologies do you leverage, and where do you see the future of that going?
Yeah, absolutely. So I think it's a little bit of that ADHD, always looking for something new. I used to give myself a hard time for always like not having a to-do system. Like I'm 46 years old, I should have an established to-do system. And I finally realized like maybe it's switching to something new, and that's what I need. Like having something will work for 6 months, a year, and then I get bored of it and I'm not using it.
Oh,
and so
interesting.
switching to something new is actually what I need to have a good to-do system.
Yeah.
So for me, it's not, I've got this thing figured out and I'm going to use it till the end of time.
Yeah.
It's, I'm going to keep trying things. And it's not necessarily that I am looking for something better, but I'm also looking for something new.
Yeah.
That doesn't get tiring, like shifting your stuff between these platforms. Like you're talking about like a productivity.
Yeah. So I've been on Todoist for a while.
Todoist.
And
Heard of it.
you can do it on browser. You can do it on a phone, computer, install. I can do it on my watch.
Neat.
So I love it, and I use it still to record stuff. Like I'll add stuff to Todoist, and sometimes just the fact of adding it is what I need to like sink it into my brain.
Right.
I don't, and then I'll go like a week without looking at what I've actually put there. So I will admit, like I appreciate your recognition of me trying to pull in that stuff that's going to be better. I don't know. I think email's got a lot of flaws. So I like using Slack. I use
Right.
Slack because RIT's paid for the professional version, right? I've tried all these things. I really now try to avoid having people log in with 5 different usernames, password. Like, I don't want you to go set something up on your own. I want to use something that's built into the
Sure,
RIT
sure.
environment.
Yeah.
I like Slack because you can get into a thread and people don't have to see that unless they want to see it.
Yeah.
Where email and you're doing reply all is just kind of.
It's
Yeah.
old. It's old. Yeah.
And then I love the reactions. Like, I don't want to have to say, I'm in, I want to give you a thumbs up. Or
Yeah.
like,
Sure. Yeah.
and I think that's more student centered. But not always. You know, I'm seeing as a mother of a high schooler, like how much they have one system and everything's in one system. So as far as what we were talking about, the new one I found is Loop. I really like Loop,
Interesting.
which is a Microsoft Office product.
Okay.
And what I like about it is you have these like components. And so maybe we're voting on something. And so our whole little group is working together, and we have tasks and we have a vote. And then I need to send it out to the faculty. I can take that component, send it in Outlook, and they will see it in Windows 11. So some of us are still on 10. But in Windows 11, that whole voting component will show up in your email, and you can click on the button in
That
the
is
email.
nice.
Oh,
I love
And it
interactive
updates.
Really
emails.
nice.
It updates in the component.
Yeah, that's cool.
And you can use that for tasks and project tracking and then
Keep everybody in the loop. I'm assuming.
Keep everyone in the loop.
Yeah, that's cool.
And probably the reason I like it is because it's new to me. I'm finding the new stuff that it can do.
Interesting.
So yeah, I'm always the one in the department who's like, hey, let's go do this.
That's great though.
What about technology? Like you were talking about, you were mentioning that you want to talk about VR and AR and CAD, or I know you. But yeah, let's talk about that first.
So in Onshape has an augmented reality opportunity. Creo actually does too. They've had it for a really long time. Once upon a time, I had this idea that we'd essentially put these, it was QR codes, but it was a long time ago, on the outside of a lab, and you'd have some sort of CAD model dealing with something you're doing in your lab, and a tour guide would be able to scan it on a tablet, and you'd be able to kind of spin this thing around and see kind of what they're doing in that lab.
Yeah,
That's pretty cool.
We never got there. But
That would be fun though.
so the augmented reality in Onshape, I had a iPad. It was one of the lower ends. I think it was Air. And so at spring last year chime demonstrations, I would take pictures of every group with their built chime machine, and right next to it on the table would be the CAD model, like
That's pretty
floating
cool.
on the table next to it. So design and build.
Interesting.
And then the whole team kind of behind them.
Yeah.
This, after I did that, I realized I really needed the version with LiDAR. And so I got the iPad Pro.
Yeah.
And so we just did this yesterday, last day of classes is when I do it. And so there's a team with their CAD model or their build model, and I bring up their CAD model and I put it on the table. So it was really funny to tell students like, hey, you got to move your laptop and move your headphones. They're like, what? I'm like, I'm gonna put the CAD model here. And they're like,
Like, what do you mean?
what? And so I bring up the CAD model. There's the model. It's like, CAD model's 2 inches shorter. Did you change your model? Like,
Yeah,
and they're like,
you
oh
can
yeah,
tell
we have to
that.
make it taller. And I'm like, because with LiDAR, it projects it to scale.
The real
Yeah.
size.
Yeah.
That is
Because
really
it's able
cool.
to see like how far away like the top of the
Well,
table is.
I think they should have
That's
made that
really
change
good
in
though.
Onshape, because I think that's right. Because I mean, if they, well, okay, I guess
So Onshape can do it.
Yeah,
the,
yeah, yeah.
the iPad wasn't able to give enough information to Onshape to get the scale when it's being projected.
wait, so
so
it wasn't being projected to
Okay,
scale, or
so right now, with the right equipment,
Mm-hmm.
it's awesome.
yeah,
So actual ones built here, it's like 24 inches tall. The CAD model was 22 inches tall. And I asked the team, like, what's the difference? They're like, oh, we had to build it actually taller than we designed.
So it is reflecting the actual
It's
change.
res-
Yes.
Yeah, they just didn't
Okay.
update the design.
Yeah.
CAD.
okay.
I was saying they should have updated the
yeah.
CAD, but I mean,
They
I
didn't
guess,
update the CAD. And if you know, like from this project, there's design constraints. It has to fit within a box. And I am so gonna bring this
Right.
out and be like, let's see here. I don't know.
Here's your box.
And we did that actually at like week 8. Like, hey, this thing looks huge. Let's see how big it is. Like, oh gosh. And they're like, that's how big it is? I'm like, that's your design. That's
Yeah.
how big it is.
yeah.
Yeah.
it is really difficult to like design stuff with scale in mind because like the only reference for scale for someone on a computer is the scroll wheel. If like you're zooming in and out,
Right.
you can zoom all like
Ooh.
into
Yeah.
this tiny part.
Yeah.
And like, yeah, you can have dimensions that is like, oh,
No,
this
that's
is,
actually really
it's like 0.1 inch, but like you don't have a good sense of how big that is on your computer.
yeah.
That's why I always model with a caliper, especially when you're
Oh.
doing smaller things.
Oh,
right there, like
100%.
that. Yep, that's about right. Yeah, or even if you have the parts running
even
around-
just to
even
yes,
if it's even if there's
yes.
no part with me, even I
Yes.
can just
All the
see
time
it
I do
there.
that,
I
yes.
love that.
Yes,
Or like tolerances. Like, okay,
Yeah.
we're talking about 5 thou. How big is 5 thou?
sure,
Right,
sure,
you can
sure.
see it.
Yeah. And I also know that Onshape now has Apple Vision Pro integration, right?
Absolutely.
Which I guess, I mean, you could consider it, I mean, like VR, AR, I guess my understanding is VR is like you're totally encapsulated, where AR is your indirect, it's that artificial reality or augmented reality with the rest.
So Vision Pro does both.
Yeah,
Yeah.
because you have the pass through, but then
Yeah.
it's like I think that true AR is something like Meta's Orion glasses. Which
Yeah, where
they
you're
just-
actually seeing the
right,
real
where
world.
you're
Yeah.
actually seeing the real life, like not through cameras, and then it's projecting more things onto the lens. Whereas Apple Vision Pro,
It's like Jarvis
Yeah.
Yeah.
kind of
Yeah, like-
capabilities.
yeah, like everything you see in Apple Vision Pro is virtual reality because it's a screen, but they can bring in that augmented reality because of the cameras. So anyway, that's sort of neither here nor there.
Yeah.
How do you see that changing things?
I think it's going to be it's cost prohibitive at the time. But yeah, there's going to be the next version's not going to be Apple Vision Pro. Someone else is going to come in and
Right.
do the next version. So now that
sure.
it's gotten started, right? Engineers aren't going out and designing a smartphone, right? We're building on
Sure.
all of that. So now that we've got some starting points, it's going to get better. It's going to get cheaper.
Oh yeah.
So it'll get there.
Yeah.
I don't think we're going to be, I'm kind of interested. I'm starting to feel a little carpal tunnel-y from all the mousing and all the pointing. And if there's something that takes all of that physical repetitive motion away and you're just kind of like swimming through
Yeah.
computer
Really nice.
space, I think you're going to have less strain, less body concerns.
Yeah.
Which I think is good. But there'll probably be some other thing about your eyes are going to not be able to focus in the real world if you're living in a screen. There's always going to be
Right.
something.
Yeah, that's a
There's
good
always
point.
going to be something.
Like the whole thing about like a big reason why people get headaches isn't really from blue light. It's from the fact that you're at a single focal distance.
Interesting.
Yeah.
So like
didn't
when
know
you're
that.
working at your computer, even though it might show a picture of something far away, you're still just focusing on the computer screen.
And that causes a lot of eye problems too.
Yeah, eye strain.
Is that people are just looking so much closer than they used to. Like, I don't know.
Like when you're outside, you focus on the trees, and it's like, oh, now I need to focus on the sidewalk in front of me. And no, look, there's my friend Ben that's over around the corner.
What's up?
And just wait until you have to start getting bifocals and all that stuff on top of that too. So
I've been told as long as you don't start, you can go pretty long. Like my sister got glasses when she was pretty young, and it just, since getting glasses, her eyes have gotten much worse, much faster. So I don't know.
there's
Don't
an
know if that's true.
interesting. People that get glasses young actually get bifocals later.
Is that true?
Yeah.
Wow.
So you're
Otherwise,
just
it's like-
completely wrong.
Yeah, you're just
Well,
wrong.
Well,
yeah.
all
It's
my
like
anecdotal
43. At 43, you will
Really?
like there. It's so weird how it's like this, like 2-year range that people's eyes go to like not being able to focus near.
Not great design, if you ask
Yeah,
me.
it's funny. It's really interesting. Anyway,
Oh.
Need to go back
avoid
to the
it
drawing
if you
board.
can. Like,
yeah.
hold off being in your 40s as long as you can.
I'll try.
So yeah, we don't
Got a
have
few more years.
we don't have a ton of time left.
Yeah.
I'm wondering, do you have final thoughts on
Yes.
like
I have lots of thoughts.
final thoughts on like cloud-based CAD? Like maybe it doesn't have to be Onshape. Maybe it is, maybe it's not. But like cloud-based CAD versus things like SolidWorks Creo, the old-fashioned things. How important is it to switch to cloud-based? What's that timeline like? What are the things that are holding us back,
I don't think it's necessarily the cloud itself. I think it's the collaboration. I think being able to get people's ideas together, not necessarily when they're in the same location. I think just being able to get more ideas working together. I think that's why cloud is important. It's not the fact that I'm actually doing the modeling in the cloud. It's not that I'm using a web browser that's important to me. It's the fact that I can do it with other people.
But
Yeah.
I don't know that there's a good way to do it with other people without it being in the cloud.
Right.
So-
I
okay.
totally
But that's the
understand.
point.
But
Right.
I don't think it's not the fact that it's in the cloud that's important. It's the fact that you can collaborate.
Right. Which requires it to be in the cloud. And
Yeah.
so it's okay, I got you.
Yeah.
But I also think that
I would like to be able to take something that I've been collaborating and say, okay, now I need to put this over here and let it render for 2 hours. Like I need to while I'm doing that, I'm commuting.
meaning like locally, like you or
It'd be nice. Like right now, one of the things that's awesome about CAD is rendering. Like being able to make it look like it's in the real world and
Yeah.
get all that like texture.
yeah.
And that's not available in Onshape education because that's
Right.
all like high load
Right.
cloud computing. And if there was a way to take some of that and take it out of the cloud and
Yeah.
do some of that locally,
Yeah.
it would be nice. Or, you know what? Okay, we don't have access to rendering. Is there a way we can get like 10 renders a month? Like, is there something like,
yeah.
because otherwise you give a 10-year-old CAD, which seventh grade, they're teaching.
Yeah.
So 12-year-olds, they're going to want to render everything.
Right.
They want everything shiny. Like,
Yeah, yeah.
right? So maybe there's not enough cloud for that. But I think it'd be nice if there was a way to have some.
If you're making a part like every other week, and you're like, oh, I want this final
Right. Or
iteration.
just the time machine,
Yeah.
just that last thing, like,
Yeah.
because there is an aspect of engineering that is selling your design.
Yeah.
And there are ways to, put it into Blender or take it into another program and,
But it's
and
not
apply that.
integrated.
Yeah.
Or even just an offline mode, right? Like
Yeah.
right now with Onshape, you need an internet connection. And the great thing about Onshape, or one of the great things, is that, like I said before, you don't need to have a really powerful computer with a great processor and an expensive machine.
Right.
You just need a web browser and like some of it's being rendered on device, but not really the computationally expensive stuff.
Right.
But if you could then bring it into an offline mode, say you're on a plane, work on it, and then push it to the cloud. I mean, I think that's the next step. I don't know. That'd be cool.
I mean, I'm sure they've heard that. I'm sure they've thought about that. But
It's tough.
Yeah.
Because so Onshape's built on like versioning.
Yeah.
And if you pull something offline, you work on it, and somebody else is working on it in the cloud, now you have to rectify those changes.
You've lost your advantage. But there's always trade-offs, right? Everything we do has a trade-off. So
Yeah. All right. Well, thank you so much.
Yeah.
no, it's been fun.
pleasure.
This was fantastic.
Everyone knows
having
I
you
will
on.
talk about CAD
Yeah.
all the time.
No, we love it.
Even though this was perhaps within ME and not beyond. It was great to have you on and to hear your perspective.
Yeah.
Absolutely fantastic to talk with you. It's always great conversing about CAD and FIRST.
And when this comes out, I'm sure I'll have to have said, I hope you did good on finals and you're enjoying your break.
Thank you so much.
Take care.
Bye-bye.
All right.